Hello, we are here for one more lesson of this T-FLEX analysis training course, and the topic for today will be the static analysis. We will start a new set of videos, and these are the last set until the end of this course, where we will see more detailed topics about all the different types of analysis that we are able to perform inside T-FLEX. And besides this type of analysis, there are details or characteristics inside each one of the possible calculation that we will see with a little more detail. So today we will talk about the static analysis. And we can start this by mentioning that the main goal of this static analysis of structures is the evaluation of the stress state of a structure, element, whatever you may have, subjected to a constant force in time. That's why we call static. This evaluation of the stress state is usually performed with the purpose of probing the adopted design features against the strength criteria. There is a formulation about these strength criteria. Please check our theoretical course to see that formulation, because it's a definition, but I think it is important. This module of the static analysis inside T-FLEX serves for calculating a static stress state of a 3D structure inside T-FLEX CAD environment. And this is, as you know, one of the big advantages of this software solution. This analysis module works directly with 3D T-FLEX CAD modules and does not require any additional constructions to obtain a solution for this particular type of calculation. The main results that we can obtain from a static solution are some of them are shown here. As you can see, the factor of serving, displacements. Let me be a little more specific, but here the purpose was to show you a little about what we can obtain in some with this static analysis. But being a little more detailed, we can obtain structure displacements in specific points. We can obtain the relative strain field, stress components field, strain energy, node response, and the field of the strain safety factor distribution over the volume of all the structure. This kind of data usually it's enough for predicting the behavior of the structure or elements in study, and to make decisions to optimize the geometrical shape of the part or of the structure that you are studying. So this is a basic introduction for this static analysis. I hope that these explanations are clear enough. Anyway, I think it would be important to check and to see our videos for static examples that we have also released in our YouTube channel. Any question, any help or support that you may need, send us your ideas, your questions, whatever, through the usual channels.